Right. Good morning, everyone. My name is Björn Ritzl, Principal Engineer and Product Owner at King. I have a colleague with me as well, Matthias. Wave to the audience, Matthias. Francois, by the way, he mentioned the issue with the badges. So I was previously, the badge said my name was Ryan Ritzl. I think it had quite the nice ring to it. So who's Ryan? Whose name did I steal? Yeah. And who was unfortunate enough to get my name, Björn? Any Björn in the audience? Oh, it's a very Swedish name. So I'm from Sweden. We're both, me and Matthias work at the Stockholm office at King. As Francois mentioned, I'm going to talk a little bit about debugging. I'm going to give you a quick intro to the company we work for, the game engine we work with, and then a couple of slides about debugging HTML5 applications. So it's going to be a lightning talk, so we'll be done in maybe 5 minutes. So we work at King, game developer. King has released about 200 games over the years, started with like Flash games, then transitioned to games on Facebook, then mobile games. And yeah, that's where we publish most of our games nowadays. So it's on the app stores, native apps. The most popular one is Candy Crush, the most well-known. We have 268 million monthly active users, and our users swipe candies 2 laps around the globe every day. So a lot of swipes on screens going on around the world. We have 2 game engines at King, one driving most of our franchise games, like Candy Crush and Farm Heroes and those games, and then we have another game engine called Defold, where me and Matthias work. So I'm going to give you just a very quick intro or description of Defold. So it's a game engine and editor, cross-platform game engine. So we publish to native applications on mobile, desktop applications, and HTML5. It's a C engine. We use Lua for game logic. It's a 3D engine, but we have a 2D focus. So it's typically the kind of games that the King does, but it's perfectly well suited to create 3D games as well. It's component-based, very small and modular. We use it for Google Play Instant Games, Facebook Instant Games, and playable ads. So playable ads is the most extreme, I guess, where you have the application, the engine and the game running in a single file, maybe 2 meg HTML5 file. Defold was an internal engine until GDC 2016, where we decided to give it away for free, so anyone can download and use it. So it's freely available for anyone to use and build games with. We have, since then, built quite a big community of developers. I mean, it's not Unity size, of course, but it's organically growing, word of mouth. We have a ton of games being released by indie studios and small studios around the world. At King, we have a couple of games released, Blossom Blast Saga and Pet Rescue Puzzle Saga being the most well-known. And then we have indie games such as Family Age, Blast Lands, and a couple of others, like major titles built using Defold. All right, so debugging. So I'm going to just show a couple of slides and then set the stage for further discussion. So as I mentioned, we have a C++ engine, and then we have a bunch of platform-specific code on top of it to make it cross-platform. So for HTML5, it's a little bit of JavaScript glue on the top, where we use web audio, gamepad APIs, and so on. Objective-C for iOS and macOS, Java for Android, and then more C++ to cover the different desktop platforms. And the ratio between shared code and platform-specific code is maybe around 20:1. And for us, good debugging tools is, of course, a must. And since most of the code touches shared code, it's usually enough for us to debug on the host platform. So using Visual Studio or Xcode or whatever, the tools that we are familiar with as C++ developers. But what about if you have some problems specifically around HTML5 and the HTML5 platform? Then there's a different set of tools. So we, of course, use mscripten to transpile the engine code into JavaScript. We support WebAssembly. And as you probably know, mscripten can generate source maps. The browser can map these with the dev tool, so you can do all of the debugging all the way down to the C code in your browser. So that's nice. But for us, we're not coming at this from like we're not web developers. We're like game engine developers using C as our main language. So for us, it would be nice to be able to use our own debuggers, the tools that we are very familiar with. So there's probably possibilities to use remote debugging and some plugins to your IDE. But I have a feeling that there's room for improvement here. And what about WebAssembly? How do you debug that if you have problems with WebAssembly specifically? And I think Luke coming after me, he will talk specifically about WebAssembly, so I'm guessing that he has some answers here. Where's Luke? Oh, hi. So that's a bit about what we see as problems. We'd like to use our own tools, of course, the tools we are familiar with, and not specifically the browser dev tools, if possible. And then debugging graphics, it's also, of course, important for us. So we'd like to be able to inspect like the textures and the textures uploaded to the GPU. We would like to inspect shaders, draw calls, break down a frame into like how it's composed. We currently use OpenGL and WebGL, of course, looking into Vulkan as well. But what we see is that on desktop and mobile, we have RenderDoc, Xcode, and Google's Graphics API Debugger, and they're quite powerful tools. But what if we want to do the same thing on WebGL? Then there is, of course, Spectre.js, but yeah, that's your tool, right? Yeah, you're the guy behind it, right? Yes, your team. All right, kudos to you. Yeah, it seems to be the most popular and the most powerful, but I wonder, couldn't more of these tools be like integrated into the browser dev tools? I think that's an opportunity here to improve on the dev tool somehow. So yeah, lightning talk over. I've set the stage for more discussions around debugging. Thank you.